Welcome to the lecture on marine ecosystem services and goods. In this chapter, you will learn what the ocean is doing for you. And also, we will learn that we can quantify the economic value that several of the ocean ecosystem services have for us. But we will also learn that there's something beyond economically quantifiable values to ocean life. The simplest to understand ecosystem service that marine systems provides are goods such as the provisioning of food. So the world fisheries is a multi-billion economic endeavor. So every year revenues in the order of 250 billion US dollars are coming from the ocean in terms of seafood and fish. And a little bit smaller but with very fast growing revenues is the mariculture sector, where fish and also crustaceans and bivalves are grown in captivity to nourish the human population. We can also get materials from the sea that may not seem so common to some of you. For example, close to coral reefs or on coral islands, some of the building material actually comes from blocks of coral rubble. And also in former times, dried seaweeds and seagrasses have been used heavily for mattress fillings and also recently for insulation material. All these ecosystem goods, including also wood from mangrove forests and sand for building purposes, they build up to about 6 trillion US dollars yearly. Of course, all these estimates have a very, very large margin of uncertainty, but they give you the ballpark in which we find the evaluation of goods and services from marine ecosystems. Now we come to services that have to do with the regulation of fluxes of matter. Now, so what does that mean? One example that's very illustrative, I think, is the role of coastal vegetation, be it seagrasses or also macroalgae. They hold back, they absorb into their biomass nutrients that come often from land, from agriculture, and via rivers into coastal areas. Nutrient pollution, in turn, is a severe problem for coastal areas, so it's clearly a benefit and an ecosystem service if those plants absorb excess human-made, human-derived nutrients such as nitrogen and phosphorus species. And likewise, the sedimentation load from rivers is decreased very much if the water goes through this coastal filter of these macrophytes that act like a sieve, or also like a forest that combs out dust from the air in a very analogous way. And this regulating service, for a change, can be quite nicely quantified in that we ask ourselves, how expensive would a wastewater treatment plant have to be to capture that amount of nitrogen and phosphorus as a hectare of our macrophyte bed? And if we do that, if we do this economic exercise, we find quite astonishing numbers. So the equivalent in nutrient retention of macrophyte beds is in the order of 20,000 US dollars per year per hectare of these macrophyte beds. So this approach can be quite useful, of course. Also to argue for protection of such systems is called an ecological economics approach of quantifying ecosystem services in the ocean. There's more to coastal vegetation that is an ecosystem service, and that's coastal protection. Here now it starts to become really difficult to quantify the effects of corals as living wave breakers, or of marsh vegetation for helping the accretion of sediments to keep pace with the rising sea level. But evidently, given the projection of global change, of increased sea level, that's a very essential and very, very important function that those biological engineers, these engineering species, can fulfill for humankind. And then the next bigger, on a even bigger level, ecosystem service is carbon sequestration. The absorption of the excess CO2 that ultimately comes from fossil fuels into living biomass right now. One important process is the biological carbon pump in the open ocean, where phytoplankton binds the CO2 in its own biomass, gets then eaten. The fecal pellets sink down, or the phytoplankton, when dying itself, sinks down. And this way carbon is removed into deeper ocean layers, into the ocean interior, and the CO2 is removed for the time being, for longer time intervals at least, from the biosphere, and cannot work as a greenhouse gas anymore. 30% of the excess anthropogenic carbon is taken up and incorporated in living biota by the oceans. In other words, the greenhouse effect would progress much faster weren't there the oceans that do this service to us. But there's more to coastal ecosystems in the marine realm. So it has been estimated quite recently that coastal vegetation, although it only covers a tiny fraction, less than 1% of the surface of the shelf seas, that it absorbs and buries up to 10% of all carbon that's removed in the oceans as a consequence of excess human production. This is because the roots and rhizomes can build massive layers of up to several meters high. So seagrass beds in particular, they bury into the soil, into the marine sediment, just in an analogous way as forests would do this carbon into this subterranean compartment, and again effectively removing this portion of the excess CO2 from its harmful effect as a greenhouse gas. Those two carbon sequestration processes are extremely hard to quantify, and ecological economists at the moment simply do not really know how they would convert that into any meaningful number. However, people are thinking right now of giving out carbon certificates if there is a recolonization, a replanting of coastal marine vegetation that has been lost before, as to compensate so as to value that amount of carbon that would then be buried in the coming years. Then there are ecosystem services that are related to ecosystem integrity, if you want. So again, those services that depend on a healthy ecosystem with food webs that are in a healthy status are very difficult to quantify, but they are nevertheless, of course, very important, since clear and clean water is important for the next ecosystem service, and this is tourism or ecotourism. So there are huge revenues generated by tourism in coastal areas. The revenues in Europe alone are a multiple of the fisheries revenue, so tourism is clearly related to the coast and to the ocean, has become much more important than direct provisioning of goods. And of course, you can only have a working tourism that generates revenues if the ecosystem is still in a status that allows us to go diving in clear waters with plenty of fish and no degradation. And likewise, we need, of course, marine mammals if we would like to do whale watching. So here, again, we have a very tight link between economic value, ecological benefit, and the services that ecosystems can provide for us. However, we should not forget that there is a value to life beyond economics. So there's an intrinsic value to life, and philosophically and ethically, I think it helps that we clarify again and again and make ourselves aware of the fact that life originated only once. It originated in the oceans, and we, including humans, are connected to all life forms by an uninterrupted chain of being. So I think we should avoid at all costs that any branches of the tree of life in the ocean are exterminated by humans, and we should value them also intrinsically by their very existence. So to summarize, we have a relatively new approach called ecological economics that can quantify a number of ecosystem services, in particular the provisioning of food and other goods. That's relatively simple. There are some regulating services that can also be quantified. Such a quantification approach is helpful if critical decisions have to be made, for example, between coastal protection, between preservation of particular coastal habitats. However, we should not forget that there's an aesthetic and ethical value to ecosystems and to the life forms that constitute those ecosystems.